In this video, I'm going to go over central angles and arcs and chords that relate to them, okay? So we're going to be able to, by the end of today, differentiate between minor and major arcs and find and determine their degrees. We're going to also understand the relationships between central angles and arcs, okay? So a central angle is an angle whose vertex is at the center of the circle. So like here, this is a central angle because its vertex is at the center of the circle. An arc is an unbroken part of the circle consisting of 2 points called the endpoints and all the points in the circle between them. So this is arc right here. Over here on the right, y'all see this arc AC? That's an arc. So how many degrees is a circle? It's 360. So let's talk about minor and major arcs. So over here, if we're talking about the central angle ABC and we say it's 60 degrees, then that arc AC is also 60 degrees. These are equal, okay? Now, if we're talking about this arc, this major arc here, again, a minor arc is less than 180 and a major arc is 180 or greater, okay? So this is arc ADC. And again, if I said that this was 60 right here and the whole circle is 360, right? So 360 minus 60, so arc ADC would be 300 degrees, okay? And this one here is half the circle. Y'all see it? So 360 divided by 2 would be 180 degrees, and that's what that arc is. And this is going to be really, really important as we go through this lesson today, okay? So this next one says, given 2 points in a circle, the minor arc is the shortest arc linking them. The major arc is the longest arc linking them. Minor arcs may be named by 2 points, but major arcs and semicircles must be named by 3 points, okay? So we're going to do a data application here. So the circle graph shows the types of grass planted in yards of one neighborhood. So we've got a variety of grasses here, right? So this is asking us to actually find the arc, the number of degrees the arc is, okay? So hopefully you know that if we're looking at a graph like this, then all of those percentages add up to be 100, right? That's a pie chart, okay? So what we're going to do is we're going to find the measure of arc KLF. So KLF is this over here. So that's 65%, and hopefully you know that if I say 65%, I move the decimal 2 places to put it as to make it a decimal. So that would be 0.65, right? Okay. So then we're going to multiply that by our 360 degrees, and that's going to give us, I'm trying to find my key, y'all. So this is 234 degrees, okay? Now we're going to do the same thing with this other arc, FH, right here. Whoops, stop. Went too far, didn't I? So notice that we have 20 and 8 over there. So this is going to be 28. And again, we're going to move the decimal 2 places to the left. And we're just going to multiply that by 360. And 0.28 times 360 is going to be 100 degrees, 100.8 degrees, okay? So now, the next one says check out example 1. So this is a little different because it's talking about an angle. So let's see where angle FMC is. Hopefully you see that we're going to add together this 9, this 10, and this 11, right? So 9 plus 10 plus 11 is equal to 30. Once again, we're going to make that a percent, and we're going to multiply that by 360. So 0.3 times 360 is going to be equal to 108 degrees, okay? Now this next one is arc AHB. So we're going to go from A around to H all the way around to that B right there. Y'all see that? So this includes everything but the 25. So that would be 0.75%, right? Again, going to multiply that by 360. That's going to equal 270 degrees, okay? So go ahead and do the you try and come back to me when you're done. All right, so I'm going to erase all this so we can go back to ground zero. Angle EMD. Angle EMD is right there, so that's our 10%. So that's 0.1 times our 360. So that's going to be equal to 36 degrees, right? Then let's look at our DHA. So we're going D around to H and over to A. So what we want to add together is 26 and 3 and 3 and 9 and that 10 again. So that gets us 0.51. Multiply that times 360. And 0.51 times 360 is equal to 183.6 degrees. The next term we want to see here is adjacent arcs. These are arcs that are in the same circle that intersect at one point. So obviously this arc RS right here and this arc ST right here are adjacent arcs. You add them together to get the whole arc. So that's what the arc addition postulate is. So here, if I told you the arc AB was 50 and I told you the arc BC was 20, then we would do the 50 plus the 20, and arc AC would be 70 degrees. That is the arc addition postulate, okay? Now we're going to talk about BD, but before we do that, we're going to talk about what else we see in this drawing, okay? So first thing I want to show y'all is, let me do this with some colors here so we can see this a little clearer. So that's a diagonal, right? A diameter, and this is a diameter. So hopefully you guys can see these vertical angles right here. This is something you always need to look for. So this is going to be 97.4 as well. Now I see half a circle as well. So do you guys see this top half of the circle right here? So to find this section right here, we're going to do 180 minus that 97.4. So 180 minus my 97.4, and I left my notes at school, so this is 82.6 degrees, right? Now, there's a couple ways that I could solve for the last piece right here, right? So notice that we have these vertical angles here again. This is vertical to this, right? So we could do 82.6 minus the 52, and that would give us 30.6 degrees for that part right there, okay? Also, you could have added the 97.4 and the 52 and subtracted that from 180. Okay, so now this is asking us to find BD, right? So that's this arc right here. So what are we going to do? We're going to add the 97.4 plus the 30.6, and that's 128 degrees, okay? Now our other one, let's see if we can find another color here to work with. So the other one is ECB, okay? So let's make this a little thicker. ECB, so we're going to go from E around to C and up to B. Oop! So how much of the circle is that right there, y'all? ECB. ECB was half of it, wasn't it? So this is going to be 180 degrees, right? Yep. Okay. All right, so let's look at the next one. So this one, go ahead and do this one and then come back to me when you're done. So hopefully you saw these vertical angles right here. So each of these is going to be 25. And again, do you see the half circle here? So to find this piece right here, can't we do 180 minus the 25? So that's 155 degrees. Okay, and see the top half too. So if I add these two pieces together, I get 65, right? So here I'm going to do 180 minus 65. That's 115, okay? Then it's asking us for JKL. So we're going to go around J over to K and then to L, right? So we're going to add 115 plus the 25. So that's going to be 140 degrees. Now let's find this next one. Let's make this a little darker in a different color. Okay, we got L, J, N. So again, remember, you got to go in the order of the letters. So this is L, J, N over to there. And notice that that's everything but our 65. So for this one, we could do 360 minus the 65. That would give us 295 degrees. All right, so on the next one, go ahead and do these two again. Pause the video, come back to me when you're done. So this one again this is 90. Hopefully you can see that right angle, right? Notice again, we got some vertical angles here. So this is also 38 over here. And we've got half our circle again up here, right? So we could add 90 to 38, subtract that from 90 plus 38 is 128, right? 180 minus 128 is equal to 52. So this one right here is 52. Okay, and then on the bottom one, couldn't we just do 180 minus 38? So that's 142. Okay, so this is the way I like to do these. So the first one up here says find DF. And aren't we going to add 52 plus our 38, and that's 90 again. And you might have seen that right there. Y'all see that right there? Obviously that was 180 and then that part is 90, okay? So now let's also look at the other one. So the other one is HGF. So we're going from H around to G and over to F. And this time you should notice that that was half the circle, right? So this one was 180 degrees. Okay, so on the next one, I see a 90-degree angle. Do y'all see that? So this is 90 right here, right? Okay. Notice half our circle here again. So can we add the 90 plus the 74? That would be 164. And we could do 180 minus 164 for this piece right here, right? So that's going to be 16 degrees. Okay, then how are we going to find DC and CB? So again, don't we have half the circle? So couldn't we do 180 minus the 82? That would give us 98, and then we got to divide that by 2, right? So that would be 49. So this is going to be 49, and this is going to be 49. So now this one says CB. So once again, we're going to find arc CB. So arc CB right there, right? So that's 49 degrees. And then we've got arc EGC. So EG all the way up to C right there, okay? So two ways we could do this one. We could add the 74, the 16, the 82, and the 49. Or we could subtract from it 139, right? And how did I get that? I got that by combining these two pieces right here. So to find EGC, I could have done 180. No, sorry, 360. 360 minus my 139, and that's 221 degrees, y'all. Okay, so now these next two are a little different because they have equations. So all we need to know here is that a circle adds up to be 360 degrees, right? So we're going to add the 65 plus the 3x plus 4, and then don't we have two of these right here? We have two of these. You see them? They're the same. So I'm going to do plus 2 times 2x minus 19, and I'm going to set all of that equal to 360. So 3x, okay, let's go ahead and simplify this. This is going to be 4x minus 38, right? This is 65 plus 3x plus 4. Got our like terms right there, so that's going to be 7x, right? 65 plus 4 would be 69 minus 38. That's going to be plus 31, and that's equal to 360. Subtract the 31 from both sides, so that's 7x equals 329. Divide both sides by 7, so x is equal to 47, right? Now, to find arc CB, let's go ahead and find CB up here. That's this, right? So aren't we going to go ahead and do 3 times 47 plus 4? So this is equal to 145, okay? Then we're just going to find one of these, and then we're going to multiply it by 2, right? Because it's asking us for this whole part down here, okay? So I'm going to go 2 times the 47 minus 19. That was 75, and then we're going to multiply that by 2 to get our answer. So that's going to be 150 degrees. So did you guys do the U try 3? Go ahead and do it now. If not, pause the video. So, okay, once again, we're going to add 92 plus 4x plus 15 plus the 6x plus 3. Going to set that equal to 360, right? Because that's the whole circle. So we've got 10x plus 110 equals 360. Subtract the 110 from both sides. That's going to be 10x equals 250. So x is equal to 25, right? So go ahead and plug that back up in there. So it's asking us to find AB, right? So we're going to do 4 times 25. That would be, sorry, BD. Wait, skipped it. Sorry, wrong one, y'all. Let's do the one at the bottom. BD here, right? So BD's right there. So we're going to do 6 times 25. That's 150 plus 3. So this one would be 153, right? Then, yes, let's go ahead and do the top one, which is asking us for DAB. And honestly, what we could do here is just subtract the 153, right, from the 360. But let's go ahead and find what this is. 4 times 25 is 100, right? Plus 15 is 115. And if we add the 92 plus the 115, that is 207, right? Okay. All right, so the next concept in this lesson is within a circle or congruent circles. Congruent arcs are two arcs that have the same measure. So in the figure, ST is congruent to UV, right? So look, this arc is congruent to this arc because the angles are congruent. So there's three things here that you need to notice. When the angles are congruent, the chords are congruent, and the arcs are congruent, okay? So also, if the chords are congruent, then the angles in the arcs are congruent, okay? And then also, if the arcs are congruent, then their corresponding chords and angles are congruent. So if one's congruent, the other two are. Okay, that's the key here. So here it says TV is congruent to WS, and what does that mean? That means this arc, arc TV, is congruent to arc SW. So what we're going to do here is we're going to add them to, we're going to set them equal to each other. 9n minus 11 is equal to 7n plus 11. Subtract the 7n from both sides. That's going to give you 2n. Add 11 to both sides. That's going to give you 22. So you need to divide both sides by 2 here. So n is equal to 11. Now we're going to put that n back in to solve for this arc down here, WS, right? You'll see this arc down here, WS. We're going to put it there. So 7 times 11. 77 plus 11 is 88. Now I would take this back up there and put it in the top one too, because these two should be equal, just to make sure I got the right value for n. So this would be 9 times 11, which is 99, minus 11, which would also be 88. So because these are the same, then that's my check to make sure that it was correct. Okay. So this next one says that we have two congruent circles, right? And CD is congruent to EF. So because the circles are congruent, then we can then say that again, this arc is going to be congruent, arc CD is going to be congruent to arc EF. So once again, we can set those two equations equal to each other. So that's what we're going to do. 25y is equal to 30y minus 20. So I'm going to subtract 30y from both sides. So that gives me negative 5y is equal to negative 20. Divide both sides by my negative 5 here. So y is going to be equal to 4. So once again, we're going to plug that in. And if we're looking at CD here, right, isn't that 25 times 4 is 100 degrees, right? Let's check it up here. 30 times 4 is 120 minus 20. This is also 100 degrees. So once again, that's our check, okay? All right, the next one says find x. Well, again, notice we're in the same circle and those two chords are congruent. So that means that the arcs are going to be congruent, right? So this time we're just going to say 115 is equal to 7x plus 24. We're going to subtract the 24 from both sides. So 115 minus 24 is 91, right? So that's going to be 91 is equal to 7x, and then we're going to divide that by 7. So that x is equal to 13. So once again, in this case, actually we're done, right? Because it just said to solve for x. All right, so the next one, notice that we have, again, two circles that are congruent. And we have that the measure of angle CGD is equal to the measure of angle NJM. So because the angles are congruent, that means our chords are congruent, okay? So we're going to say that GD is equal to NM, right? Exactly. So we're going to say 14T minus 26 is equal to 5T plus 1, right? So we're going to subtract. I'm going to do the minus 5t on both sides. So that's going to give me 9t over here, and then I'm going to add 26 to both sides. So that's going to be 27. Divide both sides by our 9. So t is equal to 3. And then we need to plug that back in, right? Because it's asking us to find NM over here. So NM is going to be 5 times 3 plus 1. So that's going to be 16, right? And again, if we were to do that over here, 14 times 3 is 52 minus 26. Wait, is that 52? Let me see. 4 times 14 times 3. Yep. Wait, clear. 14 times 3 is 42. Sorry, minus 26. Calculators are wonderful, y'all. That is equal to 16 as well. Okay. So then VT, it says bisects this angle. So what does that mean? That means that this angle right here is equal to that angle right there, because if the angle is bisected, it creates two congruent angles, right? So once again, that means this chord is congruent to that chord. So once again, we could say RT is equal to TS, right? So we're going to say 6x is equal to 20 minus 4x. Add 4x to both sides. So that's going to give us 10x equals 20. Divide both sides by our 10. So x equals 2. Now let's put that 2 back in. It's asking us to find RT, right? So that's going to be 6 times 2, which is 12. And how do we check this, guys? Yep, we put it in for RS, or TS, sorry. TS is equal to 20 minus 4 times 2, that's 8. That's also 12. So there's our check.